What actually happens inside an AI agent's loop? The model gets all the attention, but the real engine is a three-part cycle and a hidden software layer. Let's open it up. Every AI agent, regardless of complexity, operates inside a continuous three-part loop: perceive, reason, act. This pattern isn't new. Simple reflex agents have been acting solely on the current percept using condition-action rules for decades. Modern intelligent agents, however, maximize an objective function by reasoning with large language models. The loop starts with perception. The agent gathers inputs from a user prompt, a camera feed, or a database query. Next, the reasoning step: the model generates a plan, decides which tool to call, or evaluates options. Finally, the act step: the agent's harness executes the chosen action, calling an API, moving a robot arm, or generating a text response. The result becomes new perception, closing the loop. This cycle is the agent's heartbeat, enabling it to pursue goals and use tools with varying autonomy. And the model is only the reasoning engine. The harness choreographs everything else. Here's a crucial insight: the LLM is just a text generator. It produces tokens in response to a prompt. By itself, it can't browse the web, query a database, or even remember the previous sentence beyond its context window. That's where the agent harness comes in. The harness is the software infrastructure that surrounds the model, managing tool use, memory, state persistence, execution environments, and feedback loops. In 2026, the shorthand agent equals model plus harness captured this relationship perfectly. The model provides the reasoning, but the harness provides the capabilities that turn reasoning into action. OpenAI's function calling API, released in late 2023, gave models a standardized way to request external tool calls. Anthropic's Model Context Protocol, MCP, from late 2024 went further, standardizing contextual awareness and tool integration. These aren't model improvements, they are harness engineering, a layer that emerged in early 2026 as a discipline broader than prompt engineering. Birgitta Bakaler of ThoughtWorks distinguishes an inner harness shipped by the model builder from an outer harness assembled by the user. The model remains the same, but the harness determines what the agent can actually do. So how does the harness actually manage tools and state? When the model outputs a function call, the harness interprets that structured output, validates parameters, dispatches the request to an API, and collects the result. That result is then serialized back into the prompt for the next reasoning step. This tool dispatch loop is what gives agents their power. State persistence is equally critical. The harness maintains a memory of past interactions, conversation turns, and intermediate steps. Context management ensures that the model has everything it needs to make an informed decision without exceeding token limits. Harness engineering designs this entire operational environment, from execution sandboxes to guardrails. The agent loop depends on the harness to store the state from previous acts and feed it into the next perceived step. Without this memory, the agent would be amnesiac, unable to build on previous successes. The inner harness provided by the model builder may handle basic tool calling, but the outer harness, assembled by the developer, integrates with specific services and enforces business rules. This layered approach is what makes agents robust. The React framework, published in a peer-reviewed paper, introduced a simple but powerful pattern. The model alternates between reasoning and acting in a loop. It first reasons about what to do, then calls a tool, then reasons about the result. This is the foundation of today's agent orchestration patterns. As agents tackle more complex workflows, the harness must orchestrate multiple LLM calls using patterns like prompt chaining, routing, parallelization, sequential processing, and planner critic. In prompt chaining, one call's output becomes the next's input. Routing sends the query to the most appropriate model or tool. Parallelization splits work into independent subtasks. Planner critic pairs a planner that devises a strategy with a critic that evaluates outcomes. These patterns are not built into the model, they are software abstractions managed by the harness. The harness coordinates execution, handles errors, and merges results. This orchestration layer is where the agent's behavior becomes truly intelligent, even if the underlying model hasn't changed. Harness engineering makes these patterns reusable and composable. In 2024, Andrew Ng popularized the term agentic, and the industry suddenly started focusing on what agents can do, not just what models can say. The biggest leaps didn't come from scaling parameters, they came from harness-level innovations. Anthropic's computer use feature, released in October 2024, lets Claude navigate computer interfaces by interpreting screens and simulating keyboard and mouse input. That's not a better language model, that's a harness that controls an operating system. Claude Code, launched in February 2025, is an agentic command line tool that delegates coding tasks via natural language. Again, the power lies in the execution environment, not the model. The infrastructure shift is so significant that the Linux Foundation formed the Agentic AI Foundation in December 2025 to ensure a transparent, collaborative evolution. Even governance frameworks like NIST's AI Risk Management Framework from 2023 and the UK's National AI Strategy emphasize the need for trustworthy AI design beyond the model. Harness engineering provides the guardrails, the interfaces, and the monitoring that make agents safe and reliable. In short, while the model generates text, it's the harness that makes it act, and that's where the real progress is. Ken Huang proposed a 7-layer AI agent reference architecture that illustrates just how much more there is than the model. It spans foundation models, data operations, agent frameworks, deployment, evaluation, security, and ecosystem. Each layer is a piece of the harness, and each must be engineered. This layered view confirms that the agent harness is not an afterthought, it's a first-class system. Looking ahead, the agent loop of Perceive Reason Act will remain the core, but the harness will grow more sophisticated, handling longer-term memory, complex tool integration, and self-healing. The equation agent equals model plus harness isn't just a slogan, it's a design principle. As harness engineering matures, we'll see agents that can plan for hours, delegate subtasks, and verify their own work, all while the underlying language model stays the same. The breakthroughs won't come from making models that think like humans, but from building harnesses that make models useful. The agent's loop is the canvas, the harness is the paintbrush. The agent loop isn't magic. It's perceive, reason, act, wrapped in a harness that turns text into action. And once you see that, you understand where the next breakthroughs will come from.